Then again, the other way around. If we want to access the value of certain memory address, then we use a star. So in here, int a, and we declare a and the star pa. Then we assign pa is the memory address of a. Then star pa equal to 3. That is equal to a's value is 3. Okay, because star pa means the memory space of which address is pa. The PA itself means memory address itself. Okay. So please practice this example. So this example. When I briefly say we declare A and B, then we declare integer pointer variable PA and PB. Then we say okay, PA represents A's memory address. And PB is the bit memory address. Then we print it out by %d and %u. %u is also the print integer, but we print out the unsigned format. So the only print out the positive one. So %d we print with %d the value of a. Then we print %u for the PA, so memory address of A. So at first, and it's the same for B and for B. So at first, this value, because we assign nothing for A, some dummy variable, and this is the real memory address of A, and this is the value of B. This is the memory address of B. Then when you say A is 3, so A's value becomes 3, but definitely A's memory address never change. Then when you say B equal to A, B's value becomes 3, but memory address is never change. But so if we say the star PA equal 4, star PA is again, it is the memory space of which the memory address is PA. That is actually A. So if we print out A here, so 4 is printed, right? Because of this statement. Then if we say star PB equal to star PA, then that means this star PB is actually B. So the B's value becomes the A's value. So at the last, the B becomes 4. So actually this star and this and these two operators actually they are complementary. Again, so the star and A is the memory address of A, and star means the value in that memory address. So star and A means it's A, just A, right? Because this one and this one is cancelled. Am I right? Because again and means memory address of this variable, and star means the variable whose memory address is this one. So this asterisk mark and the end, they are actually complementary to each other. Okay, so please practice this instrument. 자, 여러분 이거 한번 해보세요. 네. So when you run this example, you gonna see that this one, the memory, so this value of A and B is very similar. How similar with this example? However, this one, this is the memory address of A and B gonna be different from my ones. Gonna be different from the ones in the slide. That is very expected because the assign of the memory rooms is really dependent on the current situation of your machine, or it is almost random. So it's the same. So when you visit the same hotel, so whenever visit the same hotel, so you're gonna be get the different rooms, because some rooms are already occupied. So it's difficult to get exactly the same room. So it's the same. So whenever run this program, your variables gonna be assigned to the different memory space. So if you once done this one, then if you repeat it, if you execute it once again, then you're gonna see the different memory address. Okay? So because the assignment of the memory address is quite random. I'll give you the. Okay. Any question up to this point? Any question? Okay. Okay. So then let's later discuss more about the pointer variable. Okay. So pointers. Pointers is basically unsigned integer. Unsigned integer. Basically, because the memory address is started from 1 to the size of your machine's memory size. So the pointer variable can be handled as like the unsigned integer. Okay. So even though the integer is the pointer integer is a totally different variable type with the integer int itself. However, pointers can be handled. Actual value of pointer, actual value of the pointers, they are actually the unsigned integer. Unsigned integer. That's very important because we can actually some operation on these pointers. It is possible to +1 or -1 on the pointers. So we're going to discuss about it later, so please don't worry at this moment. The memory is assigned by the computer systems. So you don't have to care about which memory I have to use. But when I say the computer system here, that actually means the operating system or OS, like Windows or Linux or Android, they have or the iOS. They are all the operating systems. So that's the important thing of the operating systems. So every program actually executed over operating systems, OS, right? So in your case, all of your programs are executed on the Windows system. Am I right? Right. So the OS is very important because the OS actually doing the assigned memory to the real variables, so that you don't have to care about the assigning memory part. That is very convenient to the programmers. So if you care about all of this memory assignment, so you have to understand about what's your computers and what's your hardware size. But those are all handled by operating system. So that's why you just simply use int a and the pointer a like this. So you don't have to care about that. So this is a totally different program. Operating system actually care about the memory assignment. That's why at each time you're gonna see the different memory address for your program. So because of this reason, so here's the important thing. First, never statically assign the value to the pointer address. Never. So for example, int start PA equal 100. That means we initialize PA is equal to 100. That means PA actually pointing the memory space of which address is 100. But we never know, so what gonna be in the memory space in 100. So we should not use like this, because we never know what's in the memory in 100. And another thing is, please never use uninitialized pointer. So for example, when you say int start a, int start PA, then because this PA's value is not initialized, So the PA has some random values. Then if we say star PA equal to 100, that means please assign this value 100 to the random memory space. Some random memory space. But that memory space might be already used by some important program. Then it makes a significant error. Your whole system can be break down. So that's a problem. That is a problem. Okay. I think you're gonna understand what's the difference between this statement and this statement. In this statement, PA's value is 100. Am I right? Because int star is the data type, so PA's value is 100. However, in here, PA's value is random. Instead, star PA's value is 100. So can you see the difference? Okay, because again, int star is a data type. Okay, so let me explain. So the int is the data type of integer value, and the int star is the data type of the pointer of integers. Okay, so So this one is different, okay? The value in the memory. So the first one means when you say the int star PA equal 100, it is initialization. So we initialize the variable PA with 100. That means PA is equal to the 100. However, when we say the int star PA, then we declare PA, then star PA equal 100, that means the value in the memory of which address is PA, that value is 100. So these two are totally different in the statement. I think you understand this one. Okay, so this is the problem. So using the uninitialized memory can make a significant problem. Sometimes it can actually make your whole system, whole computer, whole Windows system. It can make the whole Windows system is break down, like the blue screen or the other problem. Just make your system die. So it is important to initialize your pointers with the empty space. So that's actually null pointer. So null pointer means pointer of which value is 0, 0. So the memory address is 0 itself, or null. So null is equal to 0, actually. So this null pointer can be represented by any pointer variable, but it is never used in any system. It is never used in the system. So when you try to assign some value to the null pointer, then the system knows, okay, it's the obvious error. Then it's stopping at that point. So by the initialize the a pointer variable with a null pointer, That is very useful to prevent further system breakdown. Okay. Okay, this is the example, another example. So please practice this one. Okay, let's see this one. What does it mean? Okay, at first we declare character C. C is the A. Then initialize with the large A. Then we also declare pointer variable for the characters. So as a star PC. Then okay, first we actually print out the value of PC and C because at this point PC is never initialized. So PC has something the random value. This is the PC's value is something random. But C's value by print %C is definitely A, right? Then here we assign PC as the memory address of C. Then that value is this one. This is the really the real memory address. They represent the variable C, right? Then here we assign by asterisk PC. Again, asterisk PC means the memory space that represented by this PC that is equal to C. So, and this asterisk PC is equal to B. That means, then if we print out PC and C, PC's memory address is the same and C is the B. Okay? Then if we assign PC equal to null, this is null, then PC is become 0, but C is still B. Okay? So this one is the expected one. So please try this one. So so at this point, by removing this, this is the comment starting from the slash star and ended by star slash. This is the commented one. Please try this one. So star PC equal to the C. That means at this point the PC is assigned by null. So we actually try to assign some null memory space. Assign C to the the null memory. Then please see what happens. Then also independently try this one. We assign something random value, something the hard static value to the PC. Then please try. Then assign to the C to this the memory address. Then please see what happens. But importantly, so in order to run these two codes, you need to change your the options. So currently, I believe your option in here is actually the debug. But please change it to the release. Then please execute. Okay, so here's another example. So you can do. So this one is very similar to the previous one, but little bit more complicated. So here we, oops. Here, so what we are doing is, okay, so we declare two variables, x and y, and integer star pointer. Then this is a pointer example, pointer variable, and x and y are the integers. And we assign x is 20, and ptr is pointer is then this ptr represents the memory address of x. Then here we first print out what's the value of x. Then that value is, let's say, 20. Maybe it is 20 because here we assign the 20 here. Then we say x is stored address %u, and this and x is printed by %u. So the output is 20 is stored at address 4104. let's assume that the X's memory address is 4104. So we print out this one. So similarly, so the same thing can be represented by star PTR and PTR, because this PTR represents the memory address of X, and star PTR is the value in that memory address. Right? So the same thing, 20 is stored at address 4104. And then let's see. % D is stored at the address %U. In this case, this pointer's value itself is 4104. Is stored address of 4106. Because this 4106 is the pointer memory address of the PTR itself. So it is stored in here. Okay? I think here is something missed one. So here is the code should be, I guess it's y equal to 20, and okay. So let's. I think it should be here. Okay, so it's like that. Then in this case we are looking at the y. So the 20, definitely this value is 20, so we print out y and y. So y's value is 20 here. 20 is stored at the other address, so the address of y. Then if we say pointer PTR equal 111, that means this pointer is pointing the memory address of X. So star PTR equal 111 means please assign this value 111 to the memory address of X. So if we print out X, that's gonna be 111. Okay, so it's not that difficult, so it's easy. Nothing difficult here. So the relationship is like that. When we declare X and Y and PTR, they have their own memory address, like 4104, 4108, 4106, something like that. But the value of the memory is empty, or something is filled with something garbages. Then when we say X equal 20, okay, so this it's not matched with that. Okay, so let's see. Okay. Oh, okay, I got the point. Okay, so here I'm sorry. Here is some problems. So in here we should have y equals star PTR. That means please assign the value in the PTR, which is X, to the Y. Okay, then Y's value is 20. Okay, so like this. So when you say X equals 20, then X value, the memory space that pointed by 4104, that space is filled with 20, right? Then if we say PTR is and X, then the memory point of X, that is 4104, is assigned to as the value of the PTR. Then so this one is put here. So the value of the PTR becomes 4104. Then when we say y equal to y is equal to the star PTR, then it actually look at the PTR first. Then by star, it find out what's the actual value that's stored in the address of the 4104. That is 20. So y's value becomes 20. And when you say the star PTR equal 111, star PTR equal 111, so it's the same. So this is the star PTR. Then it goes to the point that it actually represents. That's here. That value becomes 111. So everything is it's actually what happened in the previous example. Okay, this one should be here too. Alright. So I think it's not difficult to understand the program flow of this one. Okay. Any question? Any question about that? Alright, that's good. So this is already you practice a lot, so you don't have to worry about that. Then let me explain about the pointer of pointers. Pointer of pointers. Okay. So basically, a pointer or pointer variable is also a variable. It's a variable. That means it also needs its own memory space and its own memory address. Alright? So, memory address of a pointer variable can be stored as or stored by pointer of pointers. Pointer of pointer. Okay? So, in the example, here we declare int a. This is just an integer variable, right? Then we declare int star pa is equal to and a. Then pa is pointer of integer and its value is memory address of a. But this pa is also a variable, so it has its own memory space and its own memory address. Then how can you represent its own memory address of pointers? That is a pointer of pointer. Then we use two stars. Int star ppa is equal to end of pa. So in this case, this ppa is a new data type, pointer of pointer variables of integer variable, pointer of integer variable. It's a little confusing, but that's true. So we can actually say and PA. Definitely, we can make star triple asterisk PPA, which is pointer of pointers. Definitely, we can use four stars. Pointers. That's all possible, but we never use it. Actually, pointer is very widely used. Yes, it is used that much, but pointer. Have I seen this one? No, so I don't think I've never seen the pointer. So the pointer is very widely used, and pointer is sometimes we use it, but it's also not that much. And pointer, 3 pointers, triple pointers, I've never seen the triple pointers. So you only remember about the pointer. That's might be you may want to know at this moment. But conceptually, everything is very straightforward. Everything is the same. It's only get a little bit more confused and it has more letters. Okay, so let's see this example. In this example, we declare unsigned integer a and b. Then we also declare unsigned integer pointer variable pa and pb using star marks here. Then we also declare unsigned integer pointer of pointer variable ppa and ppb using two star marks, two asterisk marks. Okay, so let's think about when we first declare a and b. So this system also assigns some memory space for a and b, and let's assume that those memories are addressed 1 and 2. 1 is for a, 2 is for b. We also declare pointer variable pa and pb because they are variable. They should have their own memory address. Then that is. And let's assume that PA is stored, PA is assigned assigned by room 100, and PB is for the And room 101 is for PP. Okay? Then we also assign the PPA, also declare PPA, PPB. Then system assigned room 1000 for PPA and room 1001 for the PPB. When we declare, okay? You got it? So that's our situation. Then let's think about, okay, A is equal to 3. A is 3. Then this part, room number 1, the value becomes 3. And let's see, PA is AND A and PB is AND B. That means for the PA, please store A's memory address. So address 100, the value become 1. And the room the memory space, address 101, has the value 2. This 2 is the memory address of B. Okay? So it's not difficult. So it's straightforward. Then let's say PPA. PPA is equal to AND PA. AND PA. That means PPA's value is PA's memory address. What's the PA's memory address here? 100. Yes. So PPA is the memory in the memory space of the PPA of which address 1000. That is 100. And PPB is memory address of PB and PB. Then what's the value of PPB? 101. Yes, 101. Yes, 101. So in English, people like to say 101 instead of 101. Really? So the people say it's 101. So recently, the new spy movie is, the release, right? But that's, in Korean, people say 007 movie, but in English, how they say 007. 007. Okay, zero is zero, but people like to say it's zero as O because it's the same shape with O. So 007. 007. Similarly, so the 101 is opens at 101. Yes. Anyway, okay. So it's 101. PB's value is 101. Okay. So it is very simple, nothing difficult. It's very simple. Then by say star PB equal to star PA, then this B's value becomes 3. Okay. All right. You got it. You got it. All right. Then okay here. If we say percent U in percent U and the star PA and PA, then what gonna be printed out by this one? Star PA, that means the memory of which address is PA, the value in the memory of which address is PA, is star PA, is in PA. Then what gonna print it out? Three in 1. So by the first printout, what gonna print out is 3 in 1. Easily printed out. Am I right? Okay. Then what will I print out in the next? The value of PPA, the value of star PPA is stored in PPA. Okay, 100 because the star PPA is the no, it's not. It's not 100. 1 in 100. So PPA represents the memory address 100. Then star PPA means the value that is stored in memory space, memory room, memory address 100. That is 1. So 1 in 100. Okay. How about the third one? Star PPA in PPA. So let's see what's the star PPA. PPA. Star PPA can be considered as star PPA. So PPA is a pointer. So star PPA is pointer. Am I right? Star PPA is a pointer. PPA is a pointer, and star PPA is a pointer. No. So PPA is a pointer, and star PPA is just a pointer. Then, if we put another star to the pointer, that's the integer itself, right? So star PPA means PPA, the value. It's a little bit confusing. It's a little bit hard to say in words, but I believe you know what this means. So there is some value that's stored in the PPA. Okay, so let me get back. So PPA, this is the memory address of pointer of variable A. Memory address of a pointer variable of variable A. Pointer variable. Then the star PPA is the value of the pointer variable of variable A. That means address of A itself. Address of A is itself, right? So star of the star PPA is the actual value of this one. The value of this one. That means address of A. That is the value of star PPA is equal to value of address of A, that is A. So actually star is the complementary one of the address. So it actually refers the real values, right? So if we put the two stars of the pointer, that actually refers the original values. You got it? So it's a little confusing. So so let's do this one. So what is in here? Okay, first, what is the PPA? So the last one first, the PPA. The PPA has 100, right? 100. So last one should be 100. Let's say the XX in YY in. So the last one is 100, okay? So in the 100, so the star PA means the value in the 100, memory address 100, that is in the memory address 100 is 1. So this YY should be 1. Then what's the star PPA? Star PPA means this one. Star of star PPA. This star PPA is 1. That means what's the value that in the memory 1? That is 3. So the output is 3. So 3 in 1 in 100. That's actually printed out by this one. So again, this one, and the mark in the memory address, and the start is the address is the value. So address of the, so the point of the point of the pointer, address of the address of the address, that's also possible. But in order to get back, we need to use value of the value of the value of the value, something like that. So it's possible. So we can use the 2 stars is also possible. Okay. Okay. So then here is a quiz, simple quiz. So if we put another variable. What's the value of this one? So when we print out this, like this, what can we print it out? What do we print it out? Any idea? So this is star means we declare pointer. That is end of PPA. That means address of PPA. Then if we print it out the value of PPA, what will we print it out? What's the value? 네? 볼까요? 네. 네? 3이요? 3도 아닌데. 1000. 그쵸? 1000이죠, 1000. 1000 gonna print it out. Because and PPA means the memory address of PPA. Right? Memory address of PPA. So, memory of PPA is 1000. Right? We're going to print out by 2 and PPA. One. Any idea? Any other idea? One. In Chinese, E. Is it right? Yes, it's right. It actually be 1 because actually a little confusing, but PPPA is this 1000 and star PPPA is the value in the 1000, that is 100, and star PPPA means actual value, that is in the memory of 100, that is 1. So it is 1. So similarly, star PPPA, then value should be in Chinese san. Okay. You got it? You understand it? Okay, it's very confusing, but it's so confusing, but it's not difficult actually. It's very straightforward. Okay, so here is the example. Please, the practice this relation with this simple example. Okay, this one. Okay, so then let's move to the next topic. Next important topic, pointer and arrays. So this is a little bit confusing, but this is the most confusing part actually, the pointer. But pointer and the array, they are very closely related actually. They are very closely related. Basically, array, so you know what's the array. So array is a pointer. Believe it or not, array is a pointer. Array is a pointer. So here we declare int a1, a10. That means, so as I explained, we reserve 10 memory space for these a's, right? That's the definition of the array. That means, okay, so in the memory space, we reserve 10 space. Let's say, starting from 1, then until 10, 1, 2, 3, 4, 10, we reserve the 10 rooms for the integer. Okay, that's the int a10. Then we also declare star pa. Then here it is possible that we use pa equal a. Pa is equal to a. So this type of the statement is possible. Please record that it is not pa is equal to and a. Pa is equal to and a, that is wrong. It's not right. Pa is equal to a when a is array. That means this a is basically pointer. That's basically pointer. So let's see what is actually happen. So when we use this variable a itself represents the memory address of the array, integer arrays. So this a actually represents the starting point of the array. So let's think about okay. So when we declare the int a10, so 10 rooms are reserved for this array. So the first room is used by a0, and second room is used by a1. So the first room, room number 1 is for a0, room number 2 is a1, blah blah blah. Room number 10 is a9. So that's the array. So a0 is stored and memory address is 1, which means a0's memory address is 1. Then a0's memory address 1 is stored a. Then memory address is stored a. So when we say int a is 10, so if we print out a, the value of a itself, 1 is printed out. So here, then when we say ai, which is the index of this memory, this array, ai is the ith value. That is stored at the memory address a plus I. That's important. So ai is the value that is stored at a plus I. So its memory address is become a plus I. That is the memory address is again the AND AI. So the AND AI represents the memory address of the AI, and that memory address is equal to a plus I. So that's how actually how the array works. So that's why a plus I is equal to memory address and AI. Okay, so star of a plus I is also equal to AI, just AI. So actually the truth is computer or C, computer program never understand the array. They don't know what's the array actually. They actually handles everything as a pointer. They do not know what's the array. Even though we use array, that's for human programmers. Computer understand those arrays or pointers like this.